So our first talk, which is a bit longer, is coming from Norman Adkins, who is Associate Director, let me see here, at the Scientific Computing and Data Curation Division of the Environmental Protection Agency, and he'll be talking a bit about how the EPA uses Clowder. So very happy to introduce Norman's talk.
Hello, my name is Norman Adkins with the U.S. Environmental Protection Agency, and I'm here to talk briefly about EPA's journey with Clowder. We are very much early in the process, but we are quickly evolving, and much of that I will share today. So I am currently the branch chief of the Data Management and Mining Branch in the Scientific Computing and Data Curation Division at EPA. I have a bachelor's degree at Salisbury University and a master's from the University of North Carolina at Pembroke. I have been in federal service for in total about 12 years. I did have a break in service working at Cisco Systems Incorporated, and I have experience in the healthcare industry. Dr. Amar Singh is not presenting today, but he is the one that got this initiative rolling here at EPA. He is the director of the Scientific Computing and Data Curation Division. His education, he has a bachelor's degree in science, master's in biotechnology, and a PhD in bioinformatics, in addition to having a master's in business administration. He's been with EPA for a while now. He has previous experience at Syngenta as well as other employers that are listed here on the screen. I also want to acknowledge Jason Brown, who is a scientific analyst at the Environmental Protection Agency. He also was involved early in the process in getting this rolling for us. Gopa Nair, who is a contractor at the EPA, who also was one of the engineers that got this rolling for EPA, and David Smith, who works at EPA in the Office of Mission Support here at the Environmental Protection Agency. Basically, today what I'm going to do is I'm going to give you some background information about the organization so that I can start using some acronyms for these lengthy organizational names. I will talk briefly about that as well as our background as regarding the adoption of Clowder here at EPA. I'll talk about some of the federal research requirements that were a driver in EPA's installation of Clowder and its first use. I'll talk about a current use case that perhaps is our best example. We have a use case that's under development that I'd like to share with you and talk briefly about that. I'll also go over some challenges and opportunities that we have here within the agency with regard to using Clowder. And at the conference, there will be a Q&A session. This, as I mentioned, this is a recorded presentation. So brief background on EPA. EPA is a federal agency in the US federal government. Our mission is to protect human health and the environment. As EPA has about 15,000 employees, it's organized in various offices. We have 10 regional offices and multiple program offices here at EPA. But I'm just going to focus on the one that's Office of Research and Development. We're essentially the research arm of the agency. We provide the science to inform the agency's decision-making processes. ORD has 4 research centers. The one I will focus on today is the Center for Computational Toxicology and Exposure, which we're responsible for the rapid screening of chemicals and the effects on human health and the environment. CCTE for short has 4 divisions. The one I will focus on today is the Scientific Computing and Data Curation Division, which very much is an enabler of the science taking place within CCTE. So regarding the division, we're responsible for developing the internal and external applications for EPA's internal and external stakeholders. One of the more common applications is the CompTox Chemicals Dashboard at EPA, which is a publicly accessible application that provides information, scientific information of over 900,000 chemicals in the marketplace. We do perform data curation and extraction support to EPA's researchers. This includes data curation for internal and external science, internal and externally developed research. We do manage the underlying IT systems, if you will, the servers that are needed to perform the computational research within the center. We are not your traditional IT shop. We have to cater to the unique needs of the center. The computational demands are quite high. We store and manage the research data that crosses several scientific domains. Some of these are listed below, but as I will emphasize, the research that's happening within the CCTE is very much informatics type of research, bioinformatics, cheminformatics. So again, that computational need, the resources are necessary for that work to happen. We do support the development of data pipelines. We also are responsible for the data hub that we use in CCTE, which brings together several databases, harmonizes that data, and we develop essentially data marts that cater to different user groups, whether it's through an application or directly accessing the data. As far as our history with Clowder, in 2019, we initially installed Clowder, and probably our more complicated, if you will, use case was utilizing API calls. On the Contox chemicals dashboard, we display chemicals, the chemical images, the makeup of that chemical. It's displayed in the dashboard, but we're using an API call that calls out to Clowder, and the image is actually housed in Clowder and displayed on the dashboard. In 2020, and I'm summarizing, there's much more into these details here, but we started using Clowder for the data collection tool, and I'll talk about that in a minute. That's actually the use case I want to expand upon. We utilize API calls, similar for what we do for the dashboard, but it's much more, it's capturing, helping us capture a data provenance as far as the curation work itself. How did that take place? What was done? We did attempt to utilize Kubernetes, but that attempt failed. It was likely too early for us to attempt that. It is something we will revisit at a later time. This year, we did migrate to an S3 bucket for storage. It's much more cost effective for something like Clowder that can scale into the range of petabytes. So an S3 makes that a little more realistic from a budget perspective. We recently turned on public-facing features. I'll talk about that because that is related to the use case we have in development. And going forward, we're going to be looking more at data provenance for data curation beyond the data collection tool. That's a great example, but there's much more that we can do there. And I'll also talk again about the use case in development, which will allow us to support the release of that long-tail research data that is generated as part of the research activities in the center. So what drove us to adopt Clowder? It was only a couple years ago, but in 2018, there was a law that came out called the Evidence-Based Policymaking Act of 2018. The idea is when regulatory decisions, agency decision-making is occurring, the agency is responsible for releasing the data that went into that decision-making process. And at EPA, that's very much entails the research data itself. And this also requires the reproducibility of the research results that we derived at any point in time. So currently, we're doing a lot of our releases of data, when we were releasing a manuscript, that data that usually goes out with that is metadata, basically descriptive data of the raw information that we're generating as part of that research. We do not that metadata identifies where the raw data resides, but right now it's not, the tools we have do not necessarily scale to the type of data that we need to release. So, but under this evidence-based policy, the Evidence-Based Policymaking Act of 2018, that data has to be released, it has to be machine readable, and it has to be human readable, and it has to be in a format that the public can actually use. It cannot be in a proprietary format that requires a user to purchase software and install it in order for them to be able to sort through that data. So again, I'm here to talk a little bit about our current use case with Clowder, and that involves the data collection tool. I mentioned earlier, we do use Clowder for a variety of purposes, but I feel that this is the one use case that is probably the best example of how we're using Clowder to support the developing a data provenance as we're doing data curation. So Clowder is being used as a document repository for all the documents that are being curated within the data collection tool. The data collection tool, we're utilizing API calls. We populate those documents that are residing in Clowder, but are viewable through the data collection tools screen, different screens, and I'll actually show you some screenshots of what that looks like. The document viewers, they display the document in the user's browser, both when the curation is happening as well as when the reviews are taking place, for example, the management review. We are maintaining a data provenance. It's maintained as the quality control curation is always linked to a Clowder source document, and I'll expand upon that in a minute. So the process starts, basically we're using a web scraping tool that automatically uploads the documents from a database that's called the Integrated Hazard and Assessment Database to the Clowder space. So those documents are being uploaded, automated to the Clowder space where these documents are residing. We then use ETL. ETL is extract, transform, and load. So after the metadata is formatting, the document's file name and Clowder ID are loaded into the data collection tool, and we're using ETL to do that. Managers and curators can then see that the document, it's actually housed in Clowder, but they can see it on the same screen using that document viewer. So the document preview in the data collection tool, it's that preview of the document is displayed within the window itself. It does allow the user to pop the document out, essentially, that if they need to, utilize in a separate screen, it's based on the preference of the user. So that allows them to do that. It is functionality that, the document's housed in that one location, and we're not saving copies and manually manipulating that information. So the previews I mentioned are across several different screens. So there's the curator screen that is the screen that's used for the data curation of that document. The managers, once the curation is done, they have their own view to review that information, and the same feature is there on their screen as well. They're able to see the document within the data collection tool, but again, it's housed in Clowder. So the final outcome to this whole process, once we finish basically that phase of curation, we will again use ETL from the data collection tool to a separate database called the Toxicity Reference Database. We refer to that as ToxRef. We are able to add tags from the data collection tool back into Clowder. So all of that can be captured within Clowder. ToxRef that structures that information. It's several thousand in vivo toxicity studies. They're conducted within our quality guidelines and specifications, as well as consistent with the National Toxicology Program at the NIH. And it's put into a public resource that can support training and validation of predictive models. And in essence, I mentioned earlier, our mission is the rapid assessment of new chemicals. Well, traditional research methods are lengthy. They're very, very useful, but they can be lengthy and take time to get to an outcome of a result that our program offices use. So this database as a public database supports those predictive needs, essentially increasing the quantitative and qualitative information that's available from studies. And we can critically perform a rapid assessment of new chemicals using this type of information. So this is a great example of how Clowder is not only how we're utilizing the APIs and developing a data provenance, but also ties very closely into what the center's mission entails. So the use case that's under development. Right now, we have challenges with the data management side. So as research comes to an end, and I mentioned earlier that much of our research, we're doing a lot of informatics. So the data that's generated is tremendous in size. So we need a tool that scales to terabytes in some cases, gigabytes often, but occasionally you might see in the neighborhood of terabytes of data. The current tools that are available when we release a manuscript or it goes through a predefined process to get the manuscript published, those tools are not able to scale. But the number of users that need access to that data does expand. So initially you have your research team, the principal investigator, and the close collaborators and the team, and then it expands. Their management will start needing access to review the outcome of that research. Once it's at a point where management approves it, it has to be cleared within the agency. So again, the number of users begin to expand, but the data size does not change. It's quite large. And then you have peer reviewers that could be within the agency, or oftentimes they're outside of the agency performing peer reviews. So then there's that challenge of sharing that data with users that are outside of the agency, and then eventually the data is released to the public. And again, traditional means that we have in place are not able to scale to that number of users. The formats can vary significantly. So it's a challenge. So what we're doing right now, what we're looking at is uploading the data into a single location. And as the research progresses to these review stages, they can shift the data between different spaces, for example, or different collections that are made available to those different groups that are part of the research process. At the same time, as you can imagine, the data, we're not uploading it again, it's just being shared across different spaces. So that makes it available. You set the space to a certain number of users, and as you add spaces, and eventually you could have a space, for example, that's completely open to the public, then that becomes available to the public. Doing all of this without having to upload it twice. And we can utilize API calls to automate the process of getting that data into Clowder. So one of the things that I mentioned earlier, we just turned on the public facing feature. And what we've done is spaces by default are private, obviously, but we turned it on and we ran into some sort of issues with, for example, users being able to download it. So there are a lot of configurations that we were learning through this process. And I would like to thank Luigi Marini, who played a key role in helping us via the Slack channel to get us in a position where these types of issues could be fixed. So we have a space that we work with the Minnesota Department of Health. We have files out there that they can be shared. They will not need a Clowder account, and they're able to go out there and download this data. So what's next? Essentially, in this process of, I mentioned earlier about sharing research data that's quite large with the public. Well, the easy part, thanks to Clowder, is the technology's in place. We have options for how we organize the content. We can eliminate redundancy. We can automate the process of uploading data. It can scale to large sets of data, and it doesn't matter the format. Clowder is able to store that information. We're able to provide public viewing options. We can have controlled access to certain data. Then again, it can be scalable to those sizes that we need, the formats and whatnot. The hard part right now is the process, the business process, if you will. How do we structure the spaces, the collections? How do things progress as certain phases of the clearance process are completed, as an example? How will the spaces be organized? Is it by author? Is it by domain? First author, scientific domain? How are they going to organize that? There's all of these considerations that play a role in getting this done up front. And then obviously controlling the access. The peer reviewers change. So how are you going to set up new spaces, or how this is a decision that has to be made by our research, planning, and implementation staff as far as how they want the process to look like. The technology is there and it can be adapted, and it's flexible to adapt to the process rather than the other way around. And then eventually you have the adoption, which leads to one of the challenges we have today. We've turned on the public facing feature. But what's happened, and we actually have a ticket in the queue for this, but it's made all the spaces show up to the user. So if they go out there, there's 50 some spaces that are available for them to go into. Most of them, because they're default private, they're empty, but the spaces do show available. So when they go out, it can be quite overwhelming to see the number of spaces that are available to them. So that's a challenge as we consider the release of public data. Having that amount of spaces and these names that may not make sense can just be overwhelm the user and maybe counterproductive to what you're trying to accomplish. And the other thing is, we went through the spaces. We had to essentially do somewhat of an audit and get the space names changed so it didn't identify corporations, did not identify individual names, or things that perhaps might be more sensitive. So we worked with the users to do that prior to making the public-facing feature turned on. So this is one of the things that we need to address when we get to the point of releasing data through Clowder to the public user as part of our entire research process. Things that we're working on, one of the things that I'm really interested in doing is adding a lot more extractors into Clowder, whether they're custom or pre-built. Those are the ones I'm more interested in, basically to turn on more rich features of Clowder that aren't currently available right now in our instance. We do need to get what's called an authorization to operate Clowder within the agency. Initially, it was a proof of concept. Again, Dr. Singh got this rolling. It turned into a prototype, and we're now at the point where we're getting very close to production because now we're turning on these public-facing features. We are a few versions behind. We did perform some upgrades when we moved to the S3, so we do need to address that. This makes it challenging when we have bugs. Are they attributed to being behind in versions, or are they attributed to configuration issues, such as the one I mentioned earlier? We're looking to propose to use Clowder to store all research data with meta tags for data provenance. We really want to support, again, that reproducibility of our research. What was the data available at any given time when the research study was conducted? Want to expand, obviously, the use case from file storage right now to things like video analysis and development of extractors that can be done in-house or whatnot, brought in to really help turn on those rich features to enable much more research capabilities. And the other related to the use case, we do need a process for approving data for public consumption. Right now, the user can go out and they can turn on their spaces to be public facing. So that's a control type of issue, vulnerability, if you will, potentially over time. So we need to come up with a process for approving that public facing space. As far as our instance is concerned, we have, I have the statistics here. We have over 700 gigabytes of data. I want to say a couple months ago, we were probably in the 200 gigabyte range or so. So it's growing significantly. This is the website of our Clowder site. You can go out there. As I mentioned, if you go to the site, all these spaces are there. Only a few have public data that's in there. We are using an Amazon Web Services to support this in EC2 instance. Recently, the S3 bucket for the data management. Right now, it's running in Docker using Docker Compose. And again, I want to acknowledge Dr. Amar Singh, who really got this going for the agency. Jason Brown, Gopal Nair, and David Smith, who played critical roles in the technical side of getting this going for the agency. So I will stop here. Like I said, this is pre-recorded, so I think the plan is to do Q&A at the conference. Thank you for your time.
Thank you so much, Norman, for that. It's really great to get this comprehensive overview of what you're doing at the EPA. I'd like to encourage questions here. Luigi, I saw you had shared a question that looks like Norman is preparing a detailed answer for. I'm wondering if you want to read that one out loud.
Yeah, sure. So thank you for the great presentation, Norman. It's really interesting to see what you guys are doing with Clowder. So my question was, when you were showing the DCT and then you showed that you had previews, and that I assume that was a different interface from Clowder, and you were pulling in data from Clowder. I was curious to know if that interface, the DCT, was aggregating information from Clowder and other sources, or everything that you were showing on the in the screenshot was from Clowder? And if it is from other sources, just briefly, what other sources you're pulling in from?
Yeah, so the data collection tool, can you hear me first off?
Yes.
All right, perfect. Yeah, so the data collection tool, pretty much they're using, and maybe I'm not answering the question right here, but the web scraping tool, so really the original source is another database. But what they're doing is they're extracting, they're using Clowder via basically web scraping tool to pull all that data into Clowder. I'm sorry, there's a homeschool thing going on behind me too. They pull all that, the metadata and everything into Clowder so that Clowder is sort of that single repository. And then the data collection tool, obviously they're doing the curation, they're generating more metadata, which then is housed back into Clowder as far as saving sort of a provenance. But it's not, I mean, it's as far as where it's Clowder is being used as sort of that single source of record, if you will. But so it's kind of enabling, you know, when the data collection tool was, when they're doing the curation, everything's captured there. So it is a single source of record, or it acts in that capacity, especially with, you know, its capability of having all the metadata completely available within that particular space. I was trying to pull up because I'm not in the data curation, you know, as far as the details that they're doing, but I was going to paste some of the bullet points that they had in it's in a Confluence space. It's not long, but I was trying to pull it up after you asked your question. It might better explain sort of their process from a curation perspective. I don't know if that answers your question or helps.
Yes, thank you. So that data curation tool is before things get ingested into Clowder. So, and then things end up into Clowder after being scraped using that tool.
That is correct.
Thank you.
Yeah.
Got it. Thanks.
Yeah.
Well, if there are no additional questions, I just want to thank you. Really appreciated this detailed look at your work there. I know that our team here is excited to learn how you guys are using Clowder at the EPA, and we do hope that you keep us posted. So thank you again.